Hello guys, welcome back to my YouTube channel. Today I'm going to solve day 20 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I'm going to solve problem number 1140 Stone Game 2. Okay, so let's read the problem statement first. Alice and Bob continue their games with piles of stones. Okay, there are a number of piles arranged in a row and each pile has a positive integer number of stones. Okay, the objective of the game is to end with the most stones. Okay, so Alice and Bob take turns with Alice starting first, and initially m value is equal to 1. Okay, this is given to us. Okay, on each player's turn, that player can take all the stones in the first x remaining piles. Okay, so here if let's suppose if m value is 1, okay, then next player can take the piles from 1 to 2m. Okay, so if m is equal to 1, then he can select 1 to 2 piles next in the next turn. Okay, that's the simple meaning of this one. Okay, and once he decided to pick 1 or 2, then we have to update the m accordingly. Okay, so we have to update our m as max of m or x value 1 or 2. Okay, whatever he decides, if initially my m is equal to 1. Okay, so this game continues until all the stones have been taken. Assuming Alice and Bob both play optimally, we have to return the maximum number of stones Alice can get. Okay, we are only dealing with the maximum number of stones that Alice can get. Okay, Alice only. Okay, so Alice is going to make the first move. Okay, this is one important point. Okay, and whatever the value of our max, okay, m value. Okay, so that the next player, okay, can take all the stones in the first x remaining piles where x should be less than equal to 1 or less than equal to 2m. Okay, then after we are going to just update the m value. Okay, so I hope that you guys are clear with the problem statement. Now let's understand this with example number 1. Okay, so this is piles array given to us 2 7 9 4 4. Okay, so here initially the value of m is equal to 1. Okay, so now Alice has two options. Alice is going to start first. Okay, he can select this 2 or he can select this 2 7. Okay, because he can take x values ranging from 1 to 2m. Okay, so he has two options. Okay, Alice has two options, right? He can select just this 2 or he can select both 2 and 7. Okay, these are his options, right? So if he just pick this 2, then again my m is going to remain 1 only. Okay, so m is nothing but max of mx, x is 1. Okay, but if he picks these 2, then my m is going to be updated to 2. Okay, right? These are the two options. Okay, so let's suppose Alice picks 2 7. Okay, initially Alice picks both 2 7. Okay, then what is going Bob is going to do here? Bob can pick from 2 to 4. He can pick 2 to 4, right? Because my m is equal to 2. Okay, so my m is equal to 2, right? So x value is going to range from 1 to 4. Okay, so here Bob can pick from 1 to 4, right? Okay, so now if the value of my m is equal to 2, then Bob can pick from 1 to 4. And why so? Because here, see, if my m value is equal to 2, then x is ranging from 1 to 4. Okay, then Bob is directly going to pick all the piles. Okay, 9 4 4. Okay, he's going to pick all 9 4 4. So in this case, what is the total sum that I am getting? 9 plus 4 13, 13 plus 4 17. Bob is getting 17 stones in total and Alice is getting just 9. Okay, but what we need to do here, we have to find the maximum number of stones that Alice can get. Okay, so definitely this is not going to be my case, okay, for this particular example. Okay, so now let's suppose if Alice picks 2, okay, then my m is going to 1 only. Then Bob has two options. Bob can pick 7, Bob can pick just 7, or Bob can pick 7 and 9. Okay, so Bob is also thinking about his benefit here. Okay, same way Alice, she's also thinking about her benefit, and Bob is also going to think about his benefit. Okay, so now if for Bob, okay, if now he is going to pick this 7, or if he is going to pick 7 9. Okay, so let's suppose if he picks 7 9. Okay, so now my m value is going to be updated to 2, right? M value is going to be updated to 2. Then Alice has options to pick from 1 to 4, right? 1 to 4 he can pick, but that is not the size. So after 7 9, let's suppose Alice is going to pick 4 4. Okay, Alice is going to pick just 4 4. Okay, so 4 4, if Alice is going to pick, then what is the total value here I'm getting? Alice is going to pick this 4 4, and Alice is going to pick this 2. So total Alice is getting 10 here, total sum, and Bob is getting 7 plus 9 15. Bob is getting 15. Okay, so here tell me one thing. uh, this is one case, this is one case. Out of these two, which is the best case? This is best case, because Alice is getting more stones here, 10. Okay, we have to just find the maximum number of stones that Alice can get. Okay, so this is one case. Okay, Alice is getting 10 here. Okay, now next let's suppose other way. Okay, so let's say that Bob is just going to pick 7. Okay, now if my Bob is going to pick just 7, then M is again set to 1 only. Then Alice has two options again. Alice can pick 9, or Alice can pick 9 or 4. Okay, so Alice has two options. Alice can pick just 9, or Alice can pick 9 4, 9 and 4. Okay, these are the two options that Alice has. Okay, so if Alice picks 9 4, then my M value is equal to 2. Then Bob can select from 1 to 4. Okay, Bob can select from 1 to 4. Okay, so now if Alice selects 9 4, so definitely Bob is going to select 4. Okay, only Bob is remaining with 4 only. Okay, Bob is going to be remaining with 4 only. Okay, so here in this case, what are the things that Bob is picking? Bob is picking 7. Okay, then Alice is picking 9 4, and Bob is picking 4. So 7 plus 4 is 11. Bob is picking total 11 here. And what about Alice? Alice is picking 9 4 and 2. Alice is picking 9 4 and 2. Okay, so 9 10 11, 11 plus 4 15. Okay, so but why this is not the case? Why this is not the case? Tell me the reason. Because both Alice and Bob play optimally. Alice is thinking about her benefit, Bob is thinking about his benefit. Okay, so here Bob knows that instead of 7, it is beneficial for him if he just pick 7 9 directly. Okay, because otherwise he is giving Alice the chance to get the maximum profit. Okay, he doesn't want that. Okay, so here this is not going to be my case. Okay, because both Bob and Alice are going to play optimally. Okay, so here what are the max stones that Alice can get? In any case, he is going to get just 10. Okay, so here Alice is having first turn, so here he is going to pick this 2, then Bob is going to pick this 7 9. Okay, then Alice is going to pick this 2. Okay, so this is one case. Okay, Bob is also thinking about his benefit. Okay, or if Alice pick 2 7 continuously, then Bob is going to pick everything. Okay, Bob is not okay, so here if let's suppose if Alice picks 2 7, then Bob is going to pick everything, 9 4 4. Okay, he's going to pick everything. Okay, so he is also thinking about his benefit now. It's not like he is going to pick a 9 and just remain everything for Alice. Okay, so he is also thinking about his benefit only, right? So if Alice picks 2 7, then Bob has option, then he will definitely pick everything. Okay, so I hope that you guys are clear what we are doing, right? So this is for example number 1. Okay, so now let's understand this problem with example number 2. Okay, so here this is my example number 2, right? 1 2 3 4 500. Okay, so now I am going to explain how we are going to solve this problem with code. Okay, so let's understand this with the example. Okay, 1 2 3 4 5 and 100. Okay, so in code what I'm going to do, I'm going to create one suffix sum array first. Okay, these are the number of piles that we have. And then after that I am just going to create a suffix sum. Okay, and in this suffix sum, what I'm going to do, I'm going to store the sum. Okay, so if I'm just remaining with this 100, then total sum that I'm going to write here 100. Okay, if I'm just remaining with these two stones, okay, in the end, then total sum 105. If I'm just remaining with all these stones in the end, so here total sum is 109. Okay, if with all this 112, if with all this 114. Okay, and if I am remaining with all the stones, that total sum I am storing as 115 here. Okay, so this is the first thing that we need to do here. Okay, so let me just remove all this and let me just give the indexing now. Okay, so this is nothing but my 0th index, 1 index, 2 index, 3 index, 4 index, 5 index. Okay, so now I'm going to draw the recursion tree. Okay, how my code is going to work. Okay, so first thing that we need to do, we need to calculate the suffix sum. Okay, now we are going to pass this suffix sum to the max stone function. Okay, so I'm going to create one max stone function. In that I'm just going to pass. Okay, so here let's suppose that this is my function max stones. Okay, in this max stones, initially the value of max was 1. Okay, in the starting. Okay, initially the max stone value was 1, and initially I'm starting from this current index as 0. Okay, this is thing. And okay, so let's understand it like this only. Okay, so here I'm going to use few more variables like a memoization array. Okay, so that my recursion has smoothly. Okay, without need for calculating the same steps again and again. But let's understand the recursion tree first. Okay, how it is going to work. Okay, so here this is my function max stones. In this I'm just writing the initially max value. Okay, initially max till now is 1. Okay, this is given in the problem statement. M is equal to 1. Okay, and this is a starting index. Okay, now after that, okay, this is the initial step. Now after that it's going to be done for Alice. Okay, so we have two players, right? Alice and Bob. So first Alice is going to make a play. Okay, so here let's suppose Alice picks just this one. Okay, just this value. Okay, so here if we just pick this 1. Okay, and here I am going to write 1 and 2 if he picks both 1 and 2. Okay, 1 and 2 if he picks both. Okay, so now here once this is done, okay, so here definitely my ms is going to be updated. Okay, again I'm going to call this method ms, and now max is going to remain 1 only, because he is the Alice, she is picking just one stone. Okay, so max is nothing but 1 and x. Okay, so here 1 only, right? And if he picks just 1, then definitely the next Bob is going to start from here only, from this 1 index, right? So here I'm just going to write 1. Okay, see it carefully. Okay, understand it carefully, recursion tree. Okay, I am going to explain very details. Okay, so this is done. Okay, next time I'm going to call this method. Okay, now here if Alice picks these two stones, 1 and 2, okay, these two first. Okay, then here inside this my max stone function. Okay, so next time, okay, so here next time my ms here max value is going to be 2. Okay, 2, and uh, then Bob is going to start from this index. Okay, 2. Okay, this is nothing but the value of m, capital M value. Okay, capital M value initially. Okay, and here next time Bob is going to start from 2 only. Okay, this is done. Okay, now what is going to happen? So let's suppose Alice picks these two. Okay, then it's Bob's turn. So for Bob, what is the range here? X range. X range is should be greater than equal to 1 and less than equal to 2m. So here 1 is less than equal to x, less than equal to m value is 2, so 4. So Bob can pick up to 4 piles of stones, right? So Bob can pick this one, this one, this one, this one. Okay, so Bob can pick now everything. but we need to make alias as a profit. Okay, alias as a profit 1. So here now what I'm going to do, okay, he can pick everything. Okay, so now here from this step I'm just going to return he can pick everything, so just return it. After there is not going to be any turn for alias, right? So here I'm just returning what I'm returning, this suffix sum. Okay, suffix sum I'm returning for this current index value. Okay, 2. Okay, from 2 is starting now. So here I am just returning this. So suffix sum of 2 value. Okay, so let's see this 2 the index. What is there? 112 is there. Okay, so here I am returning 112. Okay, I am returning 112. Okay, why so? Why so? So alias can pick all these stone. Bob can pick all these stone items, right? So 3 plus 4. 7, 7 plus 5, 12, 12 plus 100, 112, and that is the sum that I have stored at this position. That is the use of this suffix sum. Okay, so here I have directly calculated the values. Okay, directly calculated the number of stones that Bob can collect. Okay, so this is for Bob's. Okay, Alice is only picking this 115 and 114. Bob is picking everything. Okay, Bob is also smart, Alice is also smart. Okay, so this is one case. Okay, now see here, let's come to this part now. Okay, this is done. At this step it's done. Okay, now here it's going to be Bob's turn. Okay, Alice picks just one. Now it's going to be Bob's turn. Okay, so if Bob is going to pick 2 3. Okay, Bob, let's suppose Bob is going to pick just 2. Okay, this number. Okay, and Bob is also going to pick 2 3. Okay, two options again, 2 3. Okay, Bob, Alice just picks 1. Now Bob has 2 options. Because my M is 1, simply means that my X is ranging from 1 to 2. Okay, that's a simple meaning. So Bob is picking 2 or Bob is picking 2 3. Okay, so now if Bob picks just 2, then for Alice she is going to start from 2 index. Okay, Alice. Okay, so here I am just calling this MS. Alice is going to start from 2 index and max value is again going to be 1. Okay, this is one thing. Okay, now see here. Here if Bob picks 2 3, then definitely my M value is going to be updated to 2, and if Bob picks 2 3, then Alice is going to start from 3 index. Okay, now see here. Now Alice can pick starting from what index? Okay, starting from 3 he can pick everything now, because X is ranging from 1 to 4 again, because M is 2. M is 2, so Alice can pick all the items, remaining items. Okay, so here what I'm going to do, I'm going to just return suffix sum of current index, which is nothing but 3 here, and for suffix sum 3 the value is 109. Okay, simple means this sum now, so 109 I'm returning here. Okay, this is what I'm returning, 109. Okay, so now this is done, this step is done. Okay, now see here, now again we have 2 options. Okay, now it's going to be Alice's turn. Okay, so here let me just draw this. So this is a result that we get for Bob. Okay, so here I'm just writing Bob, and this is the result. Okay, here Bob's turn, so this is the result that we get for Alice. Both are playing smart, so we have to calculate like this only. Okay, now after that it's going to be Alice's turn. Okay, Alice's turn, so she's starting from 2 index. Okay, so she has option if she just needs to pick 3 or 3 4. Okay, Alice picks 3 or Alice picks 3 and 4. Okay, so this 2 options. Okay, 2 options we have. Okay, now if she just picks 3, okay, then again I'm going to call this MS function, and in this MS function M value is going to be 1 only. Okay, so if she picks just 3, then next time she is going to start from 3 index. Okay, so here I am writing 3. Okay, now here's let's go here. Okay, so here I have to write my max tone as, so Alice is starting from 3. Okay, so here she is speaking 3 4. Okay, she is speaking 3 4. Then next time she is going to start from 4. She is going to start from 4, and M value is going to be 2. Okay, okay, so we have to check for these two. Okay, so now again here Alice speaks 3 4. So here next time it's going to be done for Bob. Okay, so here I'm just going to draw this, and inside this I'm just going to write Bob. Okay, so now Alice speaks 3 4 3 4. Okay, so now Bob is going to pick everything here. Okay, Bob is smart just like Alice. Okay, so here what I'm going to do, I'm just going to return the suffix sum of my current index, that is nothing but 4. Okay, so here I am returning 105. Okay, suffix sum of 4 is nothing but 105. Okay, this is done. This is for Bob. Okay, now let's go to this part. Okay, so let me just little bit decrement the size here. Okay, so now again we have two options here. Okay, now it's going to be done for Bob. Okay, Bob is going to pick, let's say, this 4 or 4 5. Okay, two options. Bob is going to pick 4 or Bob is going to pick 4 and 5. Again, two options we have. Okay, now if Bob picks 4, okay, this 4, then Alice is going to start from this 4 index. Okay, so here Alice is going to start from, so here I'm just going to call this MS. Okay, M is going to be 1 and Alice is going to start from 4. Okay, that's what we need to write. Okay, if Bob picks 4 and 5, then for Alice I'm going to call this method MS. Okay, and she is going to start from this 5. Okay, and M value is going to be 2. Okay, MS 2, and here it's going to be 5. Right, so same way here, MS 2 5. Okay, so here this is going to be done for Alice. Okay, this is going to done for Alice, so let me just write it, Alice. Okay, so she picks 2 5. Okay, she picks here 4 5. Bob picks 4 5. So Alice is going to pick this 100 only. So here just I'm going to return now. I'm going to return what? I'm going to return suffix sum of current index is 5. Okay, so this is going to be the output for my Alice. Okay, Alice is going to get 100. Okay, this is done. Then same way, see here. Okay, MS14. Okay, so now it's going to be done for Alice. Okay, so here I'm just going to draw, this is going to for Alice. Okay, MS14. Okay, so now Bob picks 4, then Alice can pick 5 or 100. Okay, she can pick both now because both are playing optimally. Why she need to left this 100 for someone else? Okay, so now it's Alice's turn, and she's smart here. She's going to pick everything. Okay, because if she just picks this, then Bob is going to pick this. She is not fool, right? She is going to pick everything now. Okay, until here she is playing 1 1 1 1. Okay, both are playing 1 1. But now Alice sees the opportunity. Okay, she is going to pick both. So now if she picks both, then simply means that I have to return the value at this suffix. Okay, so here I'm just going to return suffix sum at index number 4. Okay, and this is nothing but, this value is nothing but 105. Okay, this is what we need to write, return here, 105. Okay, so now this is done. Now after that what we need to do. Okay, so I hope that you guys are clear with this tree. Okay, now after this we have to do some more steps. Okay, so the recursion tree is completed here. Now see here, here can I write it like this? Okay, so MS10. Okay, so here I'm just writing MS10. Okay, and here in this side I am returning MS22. Okay, MS22, and here I am just returning the output as 112. Okay, this is what I am doing right here in this side. Okay, and in this side I am writing MS11. Okay, MS11. Okay, and here after this ms11 I am writing two things, ms12, ms23. Okay, so I'm just drawing this again. Okay, so ms12, and here I'm writing ms23. Okay, and after this ms23 is returning me, but it is returning me 109. Okay, so here I'm just writing 109. Okay, now I hope that this is much clear, right? So here ms12 it is returning me ms13 and ms24. Okay, ms13 and it is returning me ms24. Okay, so here I am returning ms24. Okay, so ms24 is returning me 105, right? And here ms13 is returning me, what is this, ms13. Okay, ms24 is returning me 105. Okay, now what I'm going to do here, ms13. Okay, so this is bigger tree now, so I am just directly going to solve this ms13. Okay, both are playing optimally here. ms13, out of these two, what is the minimum value? Okay, just tell me, out of these two, what is minimum? 105 and 100. Okay, ms13 is returning me ms14 and ms25, and ms14 here Alice is getting 105 and here Alice is getting 100. Okay, so out of these two, what value is minimum? This 100 is minimum, right? So I am just going to subtract this 100. Okay, from what? I'm going to subtract it from 109. Okay, from where this 109 is coming? 109 is coming from the suffix sum of this index 3. Okay, so here if you see ss of 3, so you will get this value 109. Okay, out of this 109 I am subtracting the minimum of these two. Okay, so here I am just going to directly write 109 minus min of 105 and 100. Okay, and here I am just going to write 9. Okay, this is done. This is going to be first step. Okay, now after that what we need to do? So here I am getting 9 and here I am getting 105. Okay, so out of these two, what is minimum? 9 is minimum, right? So I am going to subtract 9 from the suffix sum value at this index. Okay, so at 2, what is the value? 112. So 112 minus 9. Okay, so I am getting 103 here. Okay, 103 for this one. Okay, for this one I am, my output is 103. Okay, now this is done. Okay, now after that what we need to do? After that, out of this 13 and 109, what is minimum? 103 is minimum. Okay, so here I am just going to get the value of this one. So out of these two, what is minimum? Minimum is 103. Okay, and I am going to subtract it from this current index, suffix sum of 1. Suffix sum of 1 is 114. Okay, so 114 minus 103, it's nothing but 11. Okay, now I have to get the answer of ms10. Okay, so here out of 11 and 112, what is minimum? 11 is minimum, and out I am going to subtract it from 0. So ss0 is nothing but 115. Okay, so out of 115 I am minus 111, sorry, 11 only. So here what is the output that I am going to get? I am going to get the output as 104. Okay, so now you have question why we are doing this, why I am doing this, all this step. Okay, so see here, so initially it's going to be done for allies. Okay, so now what is going to be my order? Okay, so let's do that, let's understand that. Okay, so we are getting the output as 104. Okay, so here what is the best case for allies? Okay, so for allies best case is she is going to select this one. Okay, then after that Bob is also going to take care of his benefit. Okay, so what he's going to do, he is going to just select this 2 for him. Okay, then Alice is also considering his benefit, her benefit, so she is going to pick 3. Then what is Bob going to do? So Bob is thinking that if I just pick 4, then Alice is going to pick 105. If I'm picking 459, then she is going to pick 100 only. Okay, so he is going to pick both. Then Alice is going to pick 100. Okay, so what is the total output I'm getting here? 1011 104. Okay, so this is my output. Okay, so this is how they are playing, right? So now, okay, so here in each step what I'm considering, okay, what I'm considering here. So MS10, so here here Alice is thinking that if she picks just one, okay, just one, then she is getting 11. Okay, then she is just giving 11 to Bob. Okay, now here she is thinking that she picks 2, okay, 2 values, then she is giving 112 to Bob. Okay, so for her, which is the best case, to give just 11 to Bob, or to give just 112 to Bob? Okay, for her this is the best case. Okay, so that is why we are considering like that. Okay, so just see this now. So here MS12, okay, MS13, okay, MS13, okay, here. So MS13, okay, so here see, Alice is picking just 3. Okay, Alice is picking 3 only. Okay, just 3. Okay, and after that Bob has 2 options. Bob wants to pick this 4 5 or just 4. Okay, Bob wants to pick this 4 or 4 5. Okay, so for Bob, which is the best case out of these two? To pick 4 5 na, this is the best case for him na, so that Alice is only left with 100, not 105. So Bob is also playing optimally, that's the reason. So he is going to pick 100. Okay, so if he is going to pick the 100 here, okay, if he is going to pick the 100 here, so if he's going to pick the 100 here, that's what he is giving to Alice, right? So I am subtracting that from 109. Okay, so here 109, okay, at this index. So until here we have option to get 109. Okay, and total option we have 109. Okay, until here, if we haven't used any stone here. And out of this, Bob decides to give 100 to Alice only. Okay, only 100, not 105. So this is the best case for him only, right? So he is going to get only 9 only. Okay, so that's what we are calculating. Okay, 9 only he is going to get. Okay, so everyone is thinking about the best optimal case for him or her. Okay, so now I am just going to write the code for this one. Okay, so let's move to the coding part. Create one suffix sum array. Okay, so here I am just going to create one suffix sum array. Int suffix sum is equal to arrays dot copy of this piles array, and here I am just going to pass the length of my piles array. Okay, this is done. Then after that we have to fill the values in the suffix sum array. So here I am just going to run one loop for int I is equal to suffix sum dot length minus. Okay, so here I am just going to fill this 2 first. Okay, so initially see here, this is 100. Okay, let me just zoom it now. So this is 100 and this is 100. Okay, so we don't need to change it, we need to start making changes from here. So this is nothing but minus 2. Okay, suffix length and minus 2. Okay, so here from this index I have to start filling, and my I should be greater than equal to 0, and I have to decrement the value of I, and here after that I have to just update my suffix sum index plus is equal to suffix sum of I plus 1. Okay, this is what we need to do here. And once this is done, okay, then after that from this main method I'm just going to return max stones. Okay, I'm going to use this I'm going to call this method max stones, and in this I'm just going to pass my suffix sum array, and initially the max value is 1. Okay, and I am starting from 0th index. Okay, Alice is going to start from 0th index, and after that I am using the memoization, okay, to store the values that I have already calculated. So here I'm just going to initialize new memoization array. So here I am just going to give the length as piles dot length only. Okay, both. Okay, it is 2D array. Okay, piles dot length. Okay, this is done. Now after that let's write this method. Okay, so what we are going to do inside this. So here first thing, let's private int max stones. Okay, and inside this just pass my this int suffix sum array, copy it, paste it here, and then pass the value of this max. Okay, so here I'm just going to write as it as max till now. Okay, and this is nothing but 0 is nothing but my current index. So here I'm just going to write int current index. Okay, and after that I'm just going to initialize this memoization array. Okay, now inside this we have to check few things. Okay, so first thing, okay, so if my current index plus 2 into max till now, okay, if it lies outside the array, then we are going to pick all the remaining stones now. So here see, if Bob picks this one, then Alice is definitely going to pick everything. Okay, if she has chance, so she is definitely going to do that. Okay, so for that I'm just going to write one simple base condition. Okay, so here if my current index, whatever the current index that I have, in that if I just do add this 2 into multiply with max till now. Okay, so this is the range until when we are going to access the stones. Okay, number of stones. Okay, if this is equal to or greater than my suffix sum, okay, whatever the my suffix sum length, okay, if that is the case, simple base condition. Okay, it's very easy, right? So here I'm just going to return suffix sum of current index. Okay, so this is what we are doing now. Current CURR, here I am writing I and dx. Okay, so see, this is what we are doing here, right? Whenever we are returning, okay, whenever there is possibility, so I'm just returning, okay. So this is some simple base condition. Okay, and for memoization just write this if memo of, inside this just pass two values. Okay, so our current index is changing every time. Okay, so this I am passing here, and max till now I am passing here. Okay, so if I'm storing this value, okay, if I get this value, okay, initially by default all the values are 0. Okay, so if any value is greater than 0, then definitely I have already got that value in the previous case. Okay, so from here I'm just going to return memoization of, okay, just return this, that's it. We don't need to calculate the again these steps. Okay, this is done. Now here I have to calculate the int result. Okay, so here initially I am just going to give the max value. Okay, integer dot max underscore value. Okay, and now we have to find the minimum value of result for the next move possible. Okay, so that's the reason we are doing this. Okay, 105 100, which is the minimum value out of this. Okay, so we have to find the minimum value result for the next move possible. So here I'm just going to write one for loop for int I is equal to 1 and I should be less than equal to 2 into max till now, okay, and then after that I have to increment my I, Okay, and inside this I am just going to get the result. Okay, result is nothing but math.min of my result. Okay, whatever the minimum value that I am getting for the result. Okay, that's what I need to take, and I have to call this method again. So max stones, I have to call this method. In this method I am just going to pass my suffix sum. Okay, and then after that we have to find the max till now. Okay, so how I am calculating the max? So for that I am just calculating like this now, math.max of whatever the value of max till now that I have, or I value. Okay, max till now. Okay, so I have only two options now. So whatever the value of max I have until now, over the value that I'm going to select of x. Okay, that is nothing but this I. Okay, here. So this is what I need to write here for this max till now. Now I have to write the current index. Okay, so how my current index is going to look like? So here in the current index, whatever the value of I that I selected, in that I have just add this I now. If I is 1, then definitely I'm moving one step forward. That's it. And here I'm just going to pass memoization array. That's it. Okay, this is done. Now that's it. This is what we need to write here. Okay, now after that we have to memoize the difference of suffix sum, okay, at that particular position, and result. Okay, this denotes the maximum stones that can be picked. Okay, so I have to write this step now. Somewhere I have written. Let me just decrement the size. Yeah, this step we have to write now. So here we have to just update this memo of current index and max till now. Okay, so this is what I need to update here. So here I am just calculating suffix sum at this particular cur index minus res, whatever the result value that I have got. Okay, so this is what I need to do, right? And after that I have to just return. That's it. Okay, that's it. Now let's try to run the code and see if there are any code issues. So all the test cases has been accepted, right? So see here we are getting 104. Okay, and I have explained both the examples here. Okay, 104 I am getting here, and here I am getting 10, right? So now let's submit it. Okay, so see our solution is accepted, right? So I hope that you guys are able to understand today's problem. If you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.